Morning, everyone. Thanks for coming. My name is Oliver Burt. I am Principal Analytics Engineer at Virgin Media O2.
My name is Linh Perkins. I'm Senior Analytics Engineer at Virgin Media O2. So in the US, you might not have much about the name. We are one of the biggest telecom company in the UK. We were formed about 4.5 years ago via a merger between Virgin Media, which is the broadband, landline, and TV provider, and O2, which is the mobile network provider. So these two companies traditionally focus on product, which means at that time, all we wanted to know is just what's the latest phone, what's the fastest broadband that we can offer to the customer, and that is enough to draw customer to us. But nowadays, it changed. With technology development, now all that things not that appealing to customer anymore. And in order to keep customer, you need to do more. You need to focus on customer. And in order to do that, you need good data. So today, we're here to talk about how we built scalable self-service without causing chaos.
Nice. So I joined the company 4.5 years ago, so I effectively arrived as the merger happened. I was brought in on the Virgin Media side, and I was brought in effectively to be a digital challenger, to modernize the stack, bring things through to how they should be. I joined assuming that, joining a telecoms company, that the tech would be good. It was not. They'd brought in Google BigQuery almost a year before I joined. Nothing had happened with it. No one really wanted to touch it. Effectively, they wanted to keep using their on-premise system. So this was a very slow, very archaic system. Data would take a very long time to run. Once it finished running, the downstream teams had to use SQL boxes, egress the data across to those, and where they didn't trust the data produced by that central team, they then had to reprocess it, clean it, get it to how they wanted it. Being that they were using SQL boxes, the interconnectivity between them wasn't great, so it was very siloed. People couldn't see what each other were doing. There was a lot of duplication of work across the estate. The ETL process that was running was effectively owned by outsourced contractors. So changes were very difficult to make. There were very long delivery times, and you needed budget to get anything changed centrally. This led, again, to a lot of that work being done in SQL boxes, where people couldn't really benefit from it across the estate. So coming from the outside, we see that this stack needs modernization, and these processes need to change. So what was our first approach? Obviously, we all want to get a data mesh into place. There's obviously 4 pillars to the data mesh: ownership, governance, data products, and self-service. We're here today to talk to you about self-service, but all 4 of these pillars are important if you want to get the results.
So as you can imagine, with the scale of our company, there were a lot of challenges that we faced. And I grouped them into 5 different areas. Firstly, when the two companies come together, there were many legacy systems that embedded deeply into the way of working across teams. People didn't want to change. They didn't want to pick up new tools, and they felt their job security is at risk. So there was strong resistance to change. Secondly, teams operation in isolation. There wasn't enough visibility, there wasn't enough knowledge sharing across teams, and there's duplication work happening across different teams, slow development, and waste of time. And at the same time, data wasn't very inaccessible. It was quite inaccessible. This is due to multiple redundant layers of security when 2 big companies come together. You probably, at that time, didn't know what data available for you to use. Even if you knew the data you wanted to access to, but in order to get through all these layers of security, it was very difficult. And the data quality wasn't up standard that we wanted. Hence, there wasn't enough trust across team. This makes data sharing across team very difficult. Team only trust what you build. And the last but not the least, there were a wide range of technical ability across multiple teams. There were teams that never written a piece of code before. They used mainly Excel, drag and drop analytics tools. So on the other hand, there were teams that very advanced in the technology that they use, the practice that they implemented. So this make scaling or decentralize the self-service very difficult. So with all these challenges, what did we do to tackle them?
So first things first, we need to end the resistance to change. The problem here is quite a difficult one because all of these downstream teams are now quite used to this on-prem ETL process. The code is hidden away, all managed by contractors. They can't really interrogate what's going wrong. With that work being outsourced to contractors, that also happens within their own teams as well. That lack of technical involvement gives them really a lack of personal investment and almost that attitude of, I can't do anything with this, so why should I bother? So the solution to this for us was obviously why we're here. Bring in dbt Cloud, but build everything in an ELT process. So that gives everyone visibility and access to the code to see what is happening. They can now work on things themselves. They've got their own dbt projects. This gives them a sense of ownership. And importantly for us, contractors can still work within the system, but they get brought in to assist on a project, not to run a project. How to tear down the silos. So again, all this work going on in the SQL boxes, it's very difficult to share that data across. Everything's very hidden away. So the other difficulty here, again, that old on-prem system is not automic. So what this means is that data cannot be queried from that system while it's running. This means that if that process is taking until 10:30, 11 in the morning, which it frequently did, no one can do anything with data until that point. But again, where they need to use their SQL boxes, this means that they have to wait until that time, egress the data into that SQL box, run it again. Effectively, people were stuck, unable to query data until the early hours of the afternoon. So it's a huge loss of man hours there. Our solution to this, first of all, get everyone into GCP, have all of that source data ingested into one data lake. As a central modeling team, we can then model that data, make it available to data science, data products, the business layer, and the business layer is obviously where we are going to allow others to start applying that business logic. As a central team, we're only going to worry about the facts of the data. We will let our downstream teams start to apply that logic on top. That source data, we're not locking it away. It is still available if people require it, but they generally need a business case for going there. But now, everyone is in that same ecosystem. Each team has their own GCP projects to work in within that ecosystem.
So now, when everyone's on GCP, would we give access across projects to everyone? The answer is no. There are many reasons for us to do that. Firstly, staging tables. Not everyone should have access to staging tables. There will be only people who directly contribute to these downstream models that they can access and build things from it. Sensitive data shouldn't be made available to everyone by default. People will have to request access to it, and they need a business justification in order to get access to that. Hence, we follow opt-in rather than opt-out model. And then unreleased product, there are things like flaws, potentially data issue, and of course, ongoing changes in the unreleased product. We don't want to give access to everyone to this. So how do we give access to people across teams? We use Google Analytics Hub as our data sharing platform. We group our data products in different areas and manage access within the areas. Tables are intentionally grouped, which means that it also intentionally shared. Within these areas, access must be controlled from both sides, the subscribers and the publishers. In this example here, you can see at the bottom, there's fraud area, which contains sensitive data. This area is heavily controlled, and use case and business justification are required in order for people to be able to access to this area. But then on the other hand, we have the testing area where it's made widely available to people. You can add as many teams as you want. People show some interest in the products that in this area, they can use it. But we made it clear that you're not allowed to use it in production.
Nice. So next, we need to see about data accessibility. For me, this still goes into how we tackle silos. So when we model data, I don't want to have many different variations of models for different variations of tables. So I want to build one customer model that feeds everyone's needs. So how do we do that when we've got sensitive data in the customer model? So first of all, policy tagging. If we have that one model, we can apply those security measures to individual columns rather than to the table. And this means that we can make sure that if you need to have access to PII data, you can go to the security team, make your justification, and get access there.
Now, you don't have access to certain data, but you need to make a report or insights out of this data. What can you do? So what we did, we do data hashing, which we give user ability to aggregate the data that they don't have access to. And this helped to make the data sharing more easily done for everyone with the control of data protection and data security.
Next, this is more GCP specific, but we use structs to group all our columns together. That is the simplest use of structs. There's a lot of different variations of why to use them. However, we have two reasons for doing this. The first one is it's really easy for people to start putting those things through their models. So effectively, if we group everything into a struct of similar columns, rather than someone downstream having to start listing out all those columns that they want to pull through, they can just put that struct name, it's going to pull everything through, keep it all in the same format. Secondly, for downstream users, it's then very easy for them to start finding information that they might need. So if I'm building a report and I need a delivery date for an order, I go through, I can find that delivery date, but then also grouped next to it is the delivery time, the delivery driver, the slot that they picked. All of that information is now really easy to see. This is important because our tables can be 300 columns wide at times.
The last but not the least, which is metadata. Metadata is actually a very important matter that a lot of companies often overlook. It gives the context of the data, it gives the important information that it helps you to break the silos. It helps to share domain knowledge across teams without barriers. And metadata here is not just about column description. It can also be data ownership, lineage, relationship across tables. And all this information is very important for our downstream user to use the data accurately. For example, here, let's say you go into this table, you have so many options of different IDs. But with column description here, it gives you the right information to choose, to make decision which information that you need for your modeling.
Nice. Next, how do we improve the quality and reliability? So again, I don't need to preach dbt Cloud to you guys, but having that high visibility of process is going to help build confidence in people as they start using our data. Next, we can do in-process testing to make sure that issues that we find before they get to that end product. So it's better for us to slightly delay data going into a report, but have the report right, than for delivering a report fast, but getting wrong data in. And finally, having all of this done by an in-house team means that we can build up our subject matter expertise, and it makes it much easier to answer queries when downstream users want to know how to use the table. If we have outsourced contractors doing a lot of this process, they don't really have the opportunity to build up that subject matter knowledge. They only know the code. And finally, how do we adapt for the technical ability? So again, dbt Cloud, very intuitive to use, very easy to onboard people onto. But we don't really want people trying to set up dbt projects themselves. That's where things start to get complicated. This is where I need to give a big shout out to our platform engineering team who take care of all of that side for us. So at the last count, we had roughly 60 different teams using DBT. And when we take into account that we have a UAT and a prod environment, that means that we've got over 120 individual DBT projects that they've had to go through and set up across the board. As part of that, we have centralized DBT packages and centralized DBT macros. So effectively, each team that is coming onto the platform has that same starting point, even if they are operating independently. Once it goes out to GitLab, we have centralized CI/CD pipelines. So within there, we have one of code standards check, so SQL fluff, to make sure that everyone's SQL is tidy, easy to read. That's very important for kind of getting that trust across the board. Our second check is our limit zero check, which is almost null and void from the Fusion announcement yesterday, but it's going through and making sure that if you're renaming a column or renaming a table, that's not going to break everything downstream. We will still keep that in place because it's better to have 2 layers of checking.
So that's all the detailed solutions that we did to tackle all the challenges. Here, I'd like to talk about this important diagram for us to kind of explain how the operating model we use for self-service. So in this diagram, we are the central analytics team, where, just to give you the scale of it, we have, within just our area, we have 60,000 tables and models and 20,000 pipelines at the moment. So that is a central area where you do all the core foundation to support the business across multiple domain teams. The next layer is what we're doing, which is batch modeling, low latency modeling, and graph databasing. And then the next level out is where the business logic sit, the business layers. And we also plug into, our product plug into API, we've got feature store as well. And the outside layer is the scale, the simplified scale of what we support. It covers from all the domain team, finance, commercial, data science, and we also support like platform and machines as well. So with this large scale, how did we implement self-service without causing chaos? We follow 4 main pillars. Firstly, we try to achieve a unified, standardized platform. We have DBT Cloud as the main transformation tool, Google Analytics Hub as our data sharing platform, and we follow a very important principle, which is SQL first. What does that mean? It means that we try to use SQL as much as possible across every team that do data modeling. This helps to make code more accessible, visible, transparent to everyone, and people can go in and understand the logic behind the data that they have, and this makes the trust improved across team. Secondly, we decentralize ownership to domain team. Now, domain team have the flexibility to build at scale, develop, and support at speed. And they can subscribe, they can publish as well. However, we keep important operations centrally, such as we ensure that data sharing is intentional. We ensure the data protection, security, and compliance done properly. The last but not the least, in order for all of this to happen successfully, we ensure that we can enable them at scale. And in order to do that, we use shareable macros, customized templates, version control. We enforce best practice across teams, and we provide training to close skill gap.
So Linh touched there on central governance, and I just want to give a quick example of why that's very important to us. So over in Europe, we have laws called GDPR. The very simple solution to that one is it is the customer's right to either have their data deleted, to understand the data that we hold on them, or to have a decision made on their account by a human, not by a computer. The reason this is very important is that breaches in GDPR compliance carry a fine which is a percentage of your company's overall revenue. So it can be a pretty expensive fine to receive. In that old operating model, we could see that here we have an example, 3 different domains. Domain 1 fully understands GDPR, that's great. However, domain 2 doesn't know GDPR exists, which would be very worrying, and domain 3 is aware of it, but is doing it wrong. In domain 2 and 3 examples, we would be at high risk of a GDPR fine. However, with our centralized modeling, we can make sure that we apply that GDPR rule to all of our data before it gets picked up by those other domains. So we keep everything safe by doing that.
So what makes our approach unique? Here, there's 3 things I would like to talk about. Firstly, we use a hybrid data mesh approach. So with data mesh, you would like to decentralize everything. You give domain team almost everything. But for us, with our scale, we can't do that. We keep a lot of important things centrally, as I mentioned earlier. We have the central modeling area where we build the core, the foundation for everyone, not just for domain teams. So with this approach, we ensure that we give the flexibility to everyone, but we make sure that we have all these important matters that taken care of. Secondly, this is my favorite topic, sustainability. How do we scale self-service but make it last for long run? And in order to do this, we minimize technical debts. So less time on technical debt means more time on high quality development, and most importantly, more time for innovation. And this is very important for long run. An example, we successfully deploy low latency continuous flow within our pipeline. The last but not the least, we also have very important principle that we follow, which is we focus on what we best at. For example, as a central data modeling team, we don't do data ingestion. Why are we doing this? Can you imagine a machine can only run fast and smoothly when every part of it did the best of it and everyone worked together well? And why we chose dbt Cloud? Everyone knows that it's a very intuitive platform. There's a lot of inbuilt features. It supports browser-based interface. It has very smooth GitLab integration. It helps lower the barrier for user. It doesn't matter if you engineer or not, but you can go in, start developing, and then pick up things like version control. You get more understanding about the engineering concept later. And also with dbt, it has a lot of inbuilt data quality control features, tests that you can use. It makes the data product more kind of reliable. It also has very good integration with our internal comms platform, such as Slack. It helps with early warning setup that we do. It also helps to create like a secure sharing environment with granular role-based access control, single sign-on, and support multiple interconnected dbt projects. And the last but not the least, it helps us to reuse our effort. You can just spend time once to build some macros and some custom template once, but you can make it shareable and reusable for everyone.
Nice. I just want to preempt a question I'm sure most of you will come to us with after this of why are we using Google Analytics Hub rather than dbt Mesh? There's 2 answers to this one. First answer is that Analytics Hub was available to us before dbt Mesh was, so first come, first serve. However, second answer is a more important one, which is although we have dbt Cloud as our main tool across the business, there are teams using other tools for other reasons. And if we do data sharing through dbt Mesh, that then makes dbt get seen as a bottleneck for any kind of issues. So if all of our data is already sitting in Google, we should use the Google product as that sharing area. It keeps everything consistent.
So I'm sure that you will have a question for us here. What happened now after all the changes? Firstly, I would like to talk about the ETL, the old ETL process that we had in the past. It was a long process that data wasn't accessible until the afternoon, and everyone will have to wait until it finished to be able to build anything. So this will have a lot of waste time, and you can imagine with the scale, we have like 300 different users. It's a lot of time that wasted. But now in the new world, we have the central ELT process. Now, the data is ready by 8 a.m. When everyone starts in the morning, you have the data ready there to build. And also, most importantly, we have automatic processing. What that means is When the pipeline is still running, you have some already available. You can pick those up and start developing without waiting for the whole thing to finish. And this helps a lot with the scale of our organization. And we want to give everyone the ability to build things in the agile method.
Next, everything being done in that old ETL process was being built in a type 2 fashion. This is a pet peeve of mine, because essentially once tables have gone live, it's very hard to make changes or adapt. So any additional development being done, you tend to end up with tables on a V2, V3. That means people kind of get left behind, adoption becomes difficult. With our solution, our central modeling is very modular and we build in an idempotent fashion. What this means is that we get highly reusable data models that can go across the estate, and that's very fast development lead times because essentially someone comes to us with a request, we've already got all these modules that we can use to build that final product. So we get better levels of consistency across the estate.
And in the past, the domain team, they heavily relied on the central ETL team. And that became a bottleneck when the scale is so big. It was long wait, like I mentioned earlier, and it's also high cost. It was run by a large team of contractors. And people can only use unsupported SQL boxes, which is very little visibility of what the logic, the code behind it. And however, now, after the change, we have people that in domain team, now they own the product that they built, they're responsible for it, they can build at scale, and they can support at speed.
Nice. Me again, going on about type 2. Building in type 2 can lead to many issues. It gives you a high degree of technical debt, and effectively, if there's history changes that need to happen, that's where patching has to take place. And what we found in that old school world is that patching tends to introduce more issues than it's fixing. So where we build idempotently, any history that needs to be changed, we are doing as a code change, and that code change is automatically going to fix all that history on the next run of that model. So less technical debt.
And before, we had many fragmented tools across the business. It's very outdated practice that it was used. The access was quite restricted, and it's very hard to scale. But now, in the new world, we have unified and standardized platform, which means that the onboarding process is done much, much faster. There's fewer tools to learn. There more people know how to use the tool properly, and they can help each other. And the access control now can be done much easier.
Nice. Finally, what is coming up for us in the next year or two? Firstly, there's going to be changes coming to Analytics Hub, which is going to make data sharing a lot easier for us. We're going to be able to be a lot more intentional and granular with the permissions that we give to people. We are looking at data observability. So we've got Monte Carlo in, which is going to give us a good kind of generalized overview of our estate. But then we're also looking with Masthead for GCP FinOps observability. And finally, we can't be at this conference and not mention agentic AI. At the moment, we're looking for how we can use it for kind of automatic creation of data quality controls presently.
Great.
That's it.
Thanks very much.